Alright, this is video 8, and we've got one more thing to finish about currents and motions of the ocean, and then we're going to look a little bit at the chemistry of the ocean today. And there are several things that can cause these density differences in the ocean. So not only is cold water more dense than warm water, the salt sinks, and so the water in the deeper parts of the ocean is more dense due to the temperature. It's very cold. At salinity, it's very salty. So the depth of the water, all the water that's deeper, is going to be more dense than the water at the surface, which is another reason you have these deep water currents that are created due to these differences in density. You've got the warm water cooling and sinking. You've got the cool water sometimes rising and warming, and so you've got this conveyor belt motion that goes on. Because of this, sometimes cold water, when it gets warms and pushes up, it's going to bring dead, decaying matter that's going to act as nutrients for the plant producers in the upper parts of the water column. And these plant producers are going to be fertilized, and so they're going to begin to grow, and they're going to bring the small fish, and then the small fish are going to draw the large fish. And again, if you've seen Finding Nemo, you've seen that image of that spinning ball of fish, and that would have occurred where there's an upwelling, where this blast of cold water pushed up, and as it warmed and it brought the nutrient matter, created this plant growth, created food for the small fish, and then the large fish came. And we call those areas where there's a lot of fish due to the population of plants, they're called upwellings. Now, another thing we want to look at today is a little bit of the chemistry of the ocean. And the ocean is about 35 to 37 parts salt to every 1,000 parts water, and that's on average. There's some places that it's going to be saltier, obviously deeper water. Some places where it's going to be less salty, where you have rivers pushing into the ocean, it's going to be lower. We've already mentioned that salinity is the total amount of dissolved salt in water. And remember that root word SAL is Spanish for salt. Fresh water from rivers is constantly going to dilute seawater near the shoreline. Rainwater will dilute it after heavy rains and storms. So surface water's salinity is going to change a lot depending on the circumstances. Hot, dry days in the summer where there's not much rain and a lot of evaporation at the equator, it's going to be more dense. We already know that estuarine water is brackish and is a mix of fresh and salt water. Seawater does, due to its higher density, it's going to freeze at a different temperature, so that's going to be important to remember. So the deepest parts of the ocean, it might be below zero, but the water is not frozen because of the salt in it. Temperature is going to change in the ocean, all dependent on how far the sunlight reaches. And it's not going to reach but so far. So the deeper you go, the colder the water becomes because the water cannot absorb sunlight. So surface water is always going to be warmest at the equator, and it's going to be coldest at the poles. We have gases dissolved in ocean water. We know dissolved oxygen is important for any type of animal life. Carbon dioxide is necessary for all plant life to carry out photosynthesis, so they have to be dissolved in the water. Cold water is able to hold more dissolved oxygen than warm water, so we actually have a lot of life in the colder water. Here are some of the salts that you find in the ocean. We often think that sodium chloride is the only salt, but there are other salts, sodium sulfate, calcium chloride, potassium chloride, found in the water. Obviously, sodium chloride is the one that's most abundant. Surface water is where we've got plenty of sunlight, and that ranges to about 100 to 1,500 meters, 500 meters deep. And the average temperature worldwide would be about 17.5 degrees Celsius. Transition zone is where there is some sunlight, but it's coming through the shade of all this water, so it's not going to be completely dark, but you're not going to have as much sunlight, and that ranges from about 500 meters to 1 kilometer deep, and the average temperature worldwide there is 4 degrees Celsius. And then the deep zone, no sunlight is reaching it, so photosynthesis is not taking place. There's something else that serves as the producer in the food chain there. It's 1 kilometer down to the deepest parts of the seafloor, and that averages about 3.5 degrees Celsius. Another thing that's going to increase in depth besides salinity and a decrease in temperature is water pressure. And water pressure, really, if you think about it, is the weight of water. The deeper you go, all the water above you is weighing down on you, and that is what we know of as water pressure.